Have you ever pondered about the lifespan of our sun, the very source of life on Earth? An intriguing question, isn't it? We often take the sun for granted, forgetting that it's the radiant heart of our solar system, the wellspring of life as we know it. Its warmth and light are essential for our existence, fueling the photosynthesis in plants that produces the oxygen we breathe and providing the heat that allows our planet to sustain life. Our sun, this incredible celestial body, is approximately 4.6 billion years old. Just imagine, it has been burning brightly for nearly half the time that the universe itself has existed. When you consider the age of the cosmos, estimated at around 13.8 billion years, it's truly mind-boggling. But where did our sun come from? The sun's birth was nothing short of cosmic poetry. It began as a humble cloud of gas and dust, coalescing over millions of years under the force of gravity. This process heated the core, igniting nuclear fusion and giving birth to a main sequence star, our sun. Currently, the sun is in this main sequence stage, steadily converting hydrogen into helium in its core. This process releases an enormous amount of energy, which we experience as sunlight. However, this phase won't last forever. As the sun exhausts its hydrogen, it will begin to expand, becoming a red giant. This transformation will engulf the inner planets, possibly even Earth. Eventually, the sun will shed its outer layers, leaving behind a white dwarf, a small, dense and faintly glowing stellar remnant. So as we marvel at the sun, let's remember that it, like us, is on a journey through time. But don't worry just yet. Our sun still has about 5 billion years left before it exhausts its nuclear fuel and transforms into a red giant. So we have plenty of time to continue our exploration, to uncover the mysteries of the cosmos, and to appreciate the beauty of our sunlit world. Now let's delve into the concept of time in space. Does it differ from the time we experience here on Earth? To begin with, time is not just a ticking clock or a flip of the calendar page. It is a dimension just like length, width, and height. We live in a four-dimensional universe, with time being the fourth. But unlike the other three, which we can move freely in, we are all passengers on the arrow of time, moving in one direction, forward. Now let's unravel the concept of space-time. In the early 20th century, Albert Einstein proposed a groundbreaking idea which we now call general relativity. He suggested that space and time are intertwined into a single continuum known as space-time. But it's not a static canvas. Rather, it's a flexible, dynamic fabric that bends and warps under the influence of mass and energy. This leads us to another fascinating phenomenon: time dilation. According to general relativity, the presence of mass and energy warps space-time, causing time to move slower in high-gravity environments and faster in low-gravity environments. This is not some abstract theoretical concept. It's a real measurable effect. To illustrate this, consider the astronauts aboard the International Space Station. They are in a lower gravity environment than we are here on Earth. Consequently, their clock ticks a tiny bit faster than ours. Over the course of a 6-month mission, an astronaut would age less than those of us on Earth by about 0.007 seconds. It's a minuscule difference, but it's a difference nonetheless. What's fascinating is that this time dilation effect becomes much more pronounced as you approach massive objects like black holes. Near a black hole, time would slow down so much that you could watch centuries pass by in the outside universe in a matter of minutes. So time in space isn't as straightforward as it seems. It's influenced by gravity and can differ significantly from our earthly experience. In this video, we've explored the lifespan of our sun and the concept of time in space. Our radiant sun is middle-aged, sitting comfortably at around 4.5 billion years old. It's in its main sequence stage, where it's been steadily converting hydrogen into helium, yet in about 5 billion years it will swell into a red giant, bidding farewell to its main sequence days. Now let's switch gears to the concept of time in space. Time, as we know it, is a dimension, much like the three spatial ones we're familiar with. But here's the catch: it's affected by gravity. This gravitational influence causes time dilation, a phenomenon where time runs slower in stronger gravitational fields. So the next time you look up at the sun or the stars, remember, there's more to them than meets the eye. They're not just distant lights in the sky, they're reminders of the vast, complex universe we're part of. Imagine for a moment that we're embarking on a journey towards the sun, a voyage across the vast expanse of space, venturing into the heart of our solar system. As we draw closer, we're greeted by the intense heat and radiation from the sun. This is no ordinary heat. It's a blistering inferno reaching temperatures of around 15 million degrees Celsius at its core. Now, let's consider the solar wind, a stream of charged particles released from the upper atmosphere of the sun. These particles, moving at supersonic speeds, can wreak havoc on spacecraft electronics and pose radiation hazards for astronauts. Getting close to the sun presents a myriad of technological challenges. Our spacecraft would need to withstand the extreme heat and radiation, while also contending with the effects of the solar wind. It would require advanced materials, innovative cooling systems, and autonomous navigation capabilities to survive this hostile environment. A journey to the sun is a daunting yet fascinating prospect. It pushes the boundaries of our technology and understanding, offering insights into the workings of our sun and its role in shaping our cosmic neighborhood. As we continue to explore the universe, we're reminded of the immense scale and complexity of the cosmos and our place within it.